Alright, we are continuing with double angle and power reducing formula 6.3. Basically, as is clear from the title, double angle formula is used to change twice of an angle into single. So this is double, and the result when you use the formula is single angles theta. But actually you can also call this half angle, because what it does is halving the amount. Still gone. Okay, and there were two double angle formulas. I'm sorry, three: sine, cosine, and tangent. Does this mean there aren't any for the remaining trig functions, secant, cosecant, and cotangent? No, you can make their formulas again. Whenever you need one of those three, you need to use one of these. Okay, for example, cosecant, you need to use 1 over cosine 2 theta. It's 1 over cosine square minus sine square. Again, if I need cosecant 2 theta, cosecant is 1 over cosine 2 theta. All you need to do is flip and put one of these into the denominator, whichever you like. Okay, cosine square theta minus sine square theta. So by using one of the reciprocal rules, you can get the other three. So we only give you three, you can obtain the other three. For example, for cotangent 2 theta, cotangent is 1 over tangent. So you just need to flip this numerator and denominator, replace them, and that's cotangent 2 theta. Alright, I believe we have solved the first two. Yeah, this was the last thing we finished. And we are going to cover the second half of this section, which is power reducing formulas / these are called also half angle formulas. Guess why they call it half angle formulas? Because the amount on the left this time, it's not double of the right side. The left side is half the right side. Look, this is twice, this is half of this guy. Okay, so they call this half angle formulas because the left side is exactly half of the right side angle. Well, how do they obtain that? So I want to show you, for example, how they obtain sine squared. Sine squared or cos. Let me show you cosine squared. Put sine squared to the left. Cosine 2 theta. No, not that one. Sorry. Put this sine squared to the left. I'm sorry. Let's leave sine squared alone. So put 1 to the left. We get cosine 2 theta minus 1 equals minus 2 sine squared theta. And divide both sides by minus 2. Okay, so sine squared theta is equal to, I want to put the minus to the top. I will multiply both sides with a negative. So this way I don't want to have a negative on the bottom. So this becomes 1 minus cosine 2 theta over 2. Again, this becomes positive 1 here, and this becomes negative cosine there. So this is how you obtain sine squared 1 minus cosine 2 theta. Guess what happens if you isolate cosine squared? If you isolate cosine squared, solve for cosine squared, you get this one. Alright? Same way you can get the tangent as well. Or actually, tangent is sine over cosine. It's ratio of these two. Look, you take this one on the top, this one on the bottom. They share the common denominators. They will cancel it. So the result is this. Okay, tangent is sine over cosine. Alright, that's a short demonstration of how they obtain these formulas called half angle, but they actually come from double angle formulas. They are just rewritten forms of double angle formulas. So if you know these, it takes only a minute to obtain these. But just know them as well and make sure you have them on your sheet, okay, whenever you need to. This saves times. Okay, in number 3, we are going to simplify this expression. As you see, there are lots of powers. fourth power square, and they want us to change this into first powers of sine and cosine, or actually only cosine, not even sine. So these need to change. So this is the second reason the main title of these formulas is power reducing. Because these formulas, half angle formulas, are widely used for reducing power, especially in calculus. Whenever you need to take integral of such things, you're gonna start taking integrals, you will notice that having a square or power of a function in an integral is a really tough, a challenging question. So we oftentimes reduce these powers by one of these formulas. So you will recall if you take a calculus course, oh, I've seen these formulas. These formulas will be widely used there. So sometimes, whatever subject you're related to, you may need to get rid of powers around trig functions. When it is necessary, you're going to use one of these formulas. Okay? So, how do we reduce powers? How do we get rid of fourth power? Remember, these powers are reduced always half. Look, this is cosine square and this is first power. So there is no way you can reduce fourth power, fourth exponent at once. You will first reduce power 4 to 2, and then we will reduce to 1 afterwards. Okay? How? I will start with this cosine square. Instead of theta, can I use 3x? By the way, these formulas work with any expression inside. So if you use here 3x, this is going to become 6x. If you use here y, this is becoming 2y. Always you're taking double of this quantity on the right. Okay? So since I see 3x here, I will copy this formula. Instead of theta, 3x. And what will be the right side? Since it's twice the amount of the left, what is twice of 3x? It is 6x. Okay? Alright, here is the difference though. This is cosine squared. I need cosine to the fourth. Guess what I'm gonna do? I will square this and that. There you go. What is square of a square? Cosine fourth of 3x equals square of the top and square of the bottom. Okay? Well, are we going to use this in here? Is it ready? No, this is still not ready because I still see squares around terms. I need to bring everything into first power of cosine. This is not first power of cosine. This is still second power. So I still need to work on this side. First off, I'm going to FOIL this by squaring it, and I'm gonna get 1 squared plus cosine squared 6x. 2 squared is 4, by the way, right? I'm sorry, 6x and 4. Is everything fine? Are we happy? Can we go to the next line? No, there is a mistake here. Where is it? Last thing I did is incorrect. Which part? Did I incorrectly square 2? No, 2 squares 4. What did I do here? you have a sum of two items, and I have squared it by squaring the first and second. It's incorrect. We need to FOIL this thing. Okay? So it's the square of the first, square of the, I'm sorry, we need to really double this and FOIL it that way. So this is a really long question. How do we FOIL this? First item, second, inside, outside. So first terms is 1, 2 cosine 6x plus cosine square 6x is the answer. By the way, this is 4. Okay? How did I get 2 cosine 6x? 1 times cos 6x, cos 6x times 1. They are the same, so you have twice the same thing. So 2 cosine 6x. 1 times cos 6x, 1 times cos 6x. Alright, so I will take this guy here. And for sine square 3x, I will copy this formula. Look, I have a sine square formula with instead of 3x, instead of theta, I will take 3x. So it's 1 minus cosine 2 theta. But what is our theta? This is your theta. This is your theta. So imagine theta is turned into 3x. That's actually 6x, this thing. So I will just copy that answer right here. Okay? So again, this part is here, that part is here. Are we done? Is the desired requirement established here? No. What is wrong? Which one is wrong? Which one is still not ready? Yeah. This thing cosine square 6x. I still have a square here. Must be first power. So how do I write cosine square 6x now? Whenever you have a square to be reduced into single power of cosine, refer to this formula. This is for cosine square theta. I have cosine square 6x. All you need to do is make this 6x, make this 12x. 6 double, twice 6, which is 12. So we are done. This is 1, 2 cos 6x plus 1 minus cosine 12x over 2 over 4. Again, I'm replacing this by this. Anytime I have a square, I make it cosine twice the quantity inside, divide by 2. That's what it says here. Oh, is it correct though? Is this a minus? The formula says it's a plus. For cosine it's a plus, for sine it's a minus. That's the only difference. Okay? Now you can simplify this a little bit. We have everything in first power, but make sure we need to simplify this as possible, as much as possible. I have cosine 6x here, some more cosine 6x. I believe they combine. So we need to combine them. For this, here's what I'm gonna do. I will first pass this 4 to each term. 1 over 4 cosine 6x over 2 1 plus cosine 12x over 8, and this guy is 1 minus cosine 6x over 2. Wait a second. How did I get this? This part? 1 over 4. 2 over 4. Do you see 2 over 4? I cancel 2 and 4. Kinda like that. Okay? And then this is 2 over 8. 2 over 8. They combine. 2 and 4 combine into 8. Okay? Now look what's going on. Can I cross this one and this one out? Can I cross them out? Because when I combine these two denominators, they share the same denominator. Look. Common denominator. So when I combine them, cosine 6x, 1 minus cosine 6x, these two cancel. Okay? So the total is 1/4. This is completely gone. 1 plus cosine 12x over 8. And this one still survives, 1 over 2. But 1 over 2 and 1/4 can be made into, set the common denominator, 3/4. Half and a quarter makes 3/4. 3/4 plus, well, there is another 1/8 here that can be combined, right? Look, when I split this apart, there is another 1/8 coming in. So I can combine them as well by setting another common denominator. So it is 7/8, 6 plus 1, 7/8 of cosine 12x over 8. Wow, such a long one. Is it correct though? Give you a summary of our steps again. For fourth powers, you need to first reduce it to second and then reduce it to single power. I start with the second power, square it so I can get the fourth power. But when I square a sum, I need to FOIL, and when I do that, I get a square here that needs to be reduced as well. So I copy this square here and reduce it one more time by the cosine, doubling the half angle formula for cosine. And sine square is easy because it's only a square. We need to reduce it once, and that's by formula here. Just use 3x here, and it's gonna become 6x, cosine 6x, and we just copy it here. The rest is just basic algebra. Pass the denominator to each term, set common denominators, combine like terms, cancel out or combine if there are any trig functions matching, like cosine 6x and minus cosine 6x. And we will have to reduce and simplify to the power of, single power of cosine only. Okay? Alright. Now, what is this? It's now technically called half angle formulas, but no. This thing is still the same. What they did here is, you take square root of both sides. Look, this is a square. I need to get sine alone. So I cancel these and get sine theta. Look, this is actually sine theta. This is 2 theta with a square root. And whenever you take a square root, you could put plus and minus. But what did they do? Instead of using theta, they have, this was 2 theta. They have taken half of it. Instead of 2 theta, they used alpha. If this is alpha, this left side must be half of it. They call this alpha over 2. Okay? So half angle formulas and power reducing formulas are actually almost the same. It's just rewritten format. You take square root, and instead of theta you use half of alpha. This is gonna be double of half of alpha is just alpha. Can you see that again? This is important. Look, this is twice the amount here. If you put here an apple, this must be 2 apples. But if I put here a single apple, this must be half of that apple. But instead of apple notation, they used alpha. Alpha, if this is alpha, this is half of alpha. So anyways, whatever you put this side, you're always taking half on the left side. That's why they call this half angle formula. But I already mentioned that earlier. So these formulas and these ones are actually talking the same language in different symbols. One using theta, the other one is alpha. They just made it really half looking by putting 2 under it. But to be precise, to be fair, half angle formulas or power reducing formulas are actually double angle formulas. They are just rewritten form of. So double angle formulas change into power reducing formulas, and power reducing formulas change into half angle formulas, but they're all the same to me. Okay? So you can get any one of these whenever you need to, as long as you know one of them, like double angle formulas. So in the next couple questions, keep half angle formulas on the side to compute each problem. So such as it says compute cosine 75. Do we know cosine 75 on top of our head in a table? No. We know cosine 45, 30, 90, 0, 120, 150, but not 75. By the way, you can use something else from earlier chapters. You can use this sum of angles in cosine, summation formula, addition formula. But since they push us to use half angle formula, I'm not gonna do this. This is one way, one method is this. Put 45 and 30 here, compute. But since they say half angle formula, I'm going to apply half angle formula for cosine. It says put plus and minus and square root 1 plus cosine. Look, whatever the quantity here, you're taking twice of it, twice. So I see 75 here. What am I gonna put here? What is the number here? 150. And divide by 2. Alright, one exception though. You shouldn't be putting 2 options here. Cosine of an angle is unique, must be single answer. This is double answer. You're saying it can be plus or maybe minus. It's impossible. So you need to check which one is the right by looking at the quadrant of 75. 75 is in quadrant 1. This is quadrant 1. 75 is here, right? This is 75. So for an angle in quadrant 1, this is its x coordinate, this is its y. In other words, this is its cosine theta, cosine value. So what kind of sign can a quadrant 1 angle have cosine value? What kind? Plus or minus? Plus. So we need to, when you're picking this formula, you need to only pick one choice of the sign. Maybe plus or minus, but it's determined by the location, quadrant location of the angle given, provided. Alright, next use either reference angle of 150, or use the wheel values. Remember, you have all these values marked on a wheel, and get cosine 150. What is cosine 150? This is 150. What is this cosine value? I know it's negative, but I'm not sure about the angle, the coordinate. What is this? Hint, its reference angle is 30. What is cosine 30? What's that? Riley? What? Yeah, it's root 3 over 2. Okay. So you can present your answer like this, or if you want to, you can push this 2, distribute the 2 into both terms, and get 1 over 2 minus root 3 over 4. Or, I have a better idea. Let's not do this. I want to do this instead. 1 over... Nah, the first one was okay. 1 over 2 minus root 3 over 4. I will go ahead and combine these denominators, these fractions, by setting common denominator. So it's 2 minus root 3 over 4. And I will pull this 4 out as 2. Am I right? Did I do it right? 4 comes out as 2. Agree? If you agree, I'm going to enter that value then. Tell me, Ashley, you have an objection? Yeah, it looks like you're not buying it. This is wrong. 4 was in the denominator, right?
You can move the radical to the top and put 2 on the bottom. You can't move it in front.
Well, you mean like this?
Yeah.
Yes. We can take it out and it's still denominator. But if you still want to push it in front, this is how you're supposed to push it in front. 1 over 2, not 2. Again, if you want to separate this 2 out, it's 1 over 2 times 2 minus root 3. Okay? Not 2. 1 over 2 is the right choice. We went with plus. They want the 2 underneath, so I will leave it inside, okay? Square root 2 minus root 3 is the answer. Okay? They want it this way. They don't want it in front. Okay. There are 3 parts here. I will only make 1. And I think we've done a lot of sine and cosine work. Why don't we work with tangent a over 2? They have provided as a cosine of a, and they are asking for half of a. Isn't this half of a? Cosine a, tangent a over 2. So I need to get tangent a over 2 by one of these formulas. There are 3. So which one makes best sense? Would you take this formula, that, or this? You have 3 options. Think about this. Which one is the best? option 1, option 2, or option 3. Look at what's given. They're looking for a over 2. So these are a's. Imagine these are a's. Which one makes most sense to use? 1 or 2 or 3? Anyone? First one. Why? Because these are all cosines. We were only given cosine of a, not sine a. Well, can you still find sine a? Yes. You can still, if you push, you can still get sine a from Pythagorean identities. Yes, you can still use 2 or 3, but it's just longer. We don't want that. We just want to get to the result as fast as possible. So I will go with the first formula, which is 1 minus cos a over 1 plus cos a. Alright, before anything else, I want you to make a selection. Which way is correct? Plus or minus? And this is a tough one. First, which quadrant is a over 2? Which quadrant? Is it given which quadrant a is? A over 2 is? No. Wow, what a mess. They have only given this us. What does this say? This says a is in which quadrant? 270 to 360. 3 pi over 2 is 270. 2 pi is 360. A is in quadrant 4. But where is a over 2 so I can determine the sign of tangent? There we go. If a is between these two, I divide both sides, all 3 sides by 2, and I get this. 3 pi over 4. A over 2 pi. What is 3 pi over 4? It is 135. Pi is 180. So which quadrant a over 2 is in? Which quadrant? It's in quadrant 2. So in quadrant 2, tangent in an angle in quadrant 2, what sign does it take? Plus or minus? Again, tangent, if you don't know this on top of your head, tangent is sine over cosine. Sine of an angle in quadrant 2, sine of an angle in quadrant 2, cosine of an angle. Sine in quadrant 2 is plus, cosine is minus, right? Because sine is y value of an angle. Cosine is the y value of the terminal point of the angle. So it is plus over minus, it is minus. This thing is a minus. Now all we need to do is enter the given cosine value everywhere. Minus 1 minus 4/5, 1 plus 4/5. Okay? Does the work I've done here make sense? All this work is done because I need to clarify which one of these signs is gonna be valid. It's not plus, it's the minus one, because a over 2 is in quadrant 2, 135 and 180. If a is between 270 and 360. all we need is simplify this number. The top is 1/5, the bottom is 9/5. When I divide them, it becomes 1/9. And 1/9, square root of 1/9 is 1/3. So a negative 1/3 is the answer. Okay? For sine and cosine, all you need to do is enter here 4/5. 4/5, 4/5. Compute these square roots. But I'm wondering the sign. Who can tell me the sign of alpha over 2? A over 2. Plus or minus? Plus or minus for sine of an angle, half of an angle. That angle is between 270 and 360. You take half of it. I'm asking plus or minus. Which one? It's plus. This one is minus. Because sine in quadrant 2, A over 2 is in quadrant 2 is positive. Cosine in quadrant 2 is negative. Okay? Again, if you don't know that sine table, you can always get it, but we have seen it in chapter 5. If you're hesitating, go back to that sine chart. That was the first thing we have learned, I think, in chapter 5. Now you should see it. Here we go. Sine in quadrant 2, this is quadrant 2, is positive. Cosine negative, tangent is negative. Y, again, sine means the y value, positive. Cosine means the x value, negative, of that angle, that terminal point. This is called the terminal point. So keep this sine chart on your sheet behind this sheet if you want, but you need to be able to find it out. Okay, 6.4 is our upcoming section. Any questions? Again, we have learned, it looks like 3 sets of formulas, identities. Oh, it's a lot of work, but no, everything comes from double angle formulas. If you know this, you know that. If you know that, take square roots of both sides, you know these. Alright? But in any case, keep them in this sheet next to you if you want to get access to them quickly. Alright, the last section, hopefully the last set of identities, is about product sum rule and opposite sum product rule. If you are given product of pair of trig functions, sine, sine, cosine, cosine, sine, cosine, cosine, sine, pair of only the first 2 trig functions, sine and cosine, not tangent, cotangent, etc. How do we make them a sum or difference? Look, this used to be a product. Look at the new sign between them. This is subtraction. This is addition. Okay, addition. So we either change it into subtraction. It says product to sum, and most people think, oh, this has to be plus all the time. No, when we say sum, we mean plus and minus together. Subtraction is also considered a sum. Okay. So how do we change a multiplication into plus or minus between sine and cosines? There are 4 formulas here. Oh, if you want to find out how they got these formulas, all you need to do is write cosine u minus v formula. Remember cosine u, cosine v minus sine u, sine v. That formula. When you simplify things, cancel out, the only thing remaining will be sine u, sine v. So this is in the book. Very simple to prove. If you're interested, read it, but it's not waste time on it. Just directly use it, okay? So again, you don't have to memorize. You're allowed a cheat sheet for these formulas. And whenever you need to construct them, all you need to do is use sum and difference formulas for sine and cosine and simplify. Our first problem involves multiplication of a sine of an angle and sine of another angle. So you need to find out an identity involving sine-sine couple. Which one is sine-sine couple? It's this guy. Okay? So copy this right hand side, but instead of u, take 2t, and v is 5t. U is, every time I'm writing this, I will make u's into minus 2t, v's into 5t. And watch, I'm going to make a mistake here. See who's gonna spot it earlier. Alright, u is 2t, v is 5t. Yes, u is the entire thing you see inside, it's negative 2t. Any more mistakes? There's one more.
The second one says
Yeah, the second one must be positive. It says plus v plus 5t. Alright, good. Now next, simplify things. 1 over 2 minus 2t minus 5t more, it makes cosine minus 7t. And this will make cosine minus 2t plus 5t is 3t. Alright, there is one more move you can make here. What is it? Yeah? There is one more simplification you can make. It's called even-odd properties. When you have a cosine of minus x, you can do something about the minus sign. And I have a minus sign. I want to do something about it. What can I do about minus signs? We can get rid of it. And this is the same as cos x. So you can get rid of this, wipe off, get rid of this. We will have 1 over 2 cos 7t minus cos 3t. I have one more thing I can do, I believe. Can I subtract 7 and 3 make 4t, cosine 4t? Can I? No. Sine and cosine won't subtract, okay, like that. You can subtract them if they are the same in sides, like you have 5 of them, take away 1 of them, you have 4 cosine 7t. But if they are different inside, they are unlike, they won't combine. So this is our final answer. Okay? So I will try that in the answer. And meanwhile, why don't you guys work on this one? Alright, are you done? So this time we're gonna use this formula, right? Because this is a cosine product. Between two cosines, it's a product. So it's 1 over 2 cosine x over 6. Now let me first write the whole thing without inside. It's cosine and cosine, right? I have u minus v, u plus v. This is u, this is v. U minus v. X over 6 minus 7x over 6, u minus v. And u plus v, x over 6 minus 7x over 6 plus v. So it's plus. Alright. X minus 7x makes how many in total? Minus 6x over 6. But wait a minute, they cancel. So it's minus x. You can also wipe off the minus because cosine is an even function. It wipes off all negatives. And this is 8x over 6. They won't clearly cancel, but a little bit cancel to 4/3. So the final result is cosine x and cosine 4/3 of x. I wonder if we can, oh. No, it's a bad one. Cosine 4/3. Let's use this in parentheses. 4, 3, x, and one more parenthesis. Okay. No, I can't check. Let's try it. Alright, why don't you guys try this when I'm working on the next one. Next time, where instead of axis, we have a real angle, even in degrees, 82.5, 37.5. This is actually a good example of why we need these formulas. Look, because can you guys compute 82.5 with hand calculation or tables? No. But when you change this into some difference formula, some formulas, they will be conveniently nice whole values, so you can compute them. Alright, there is something wrong with my plugin. I think I need to download and install Flash again. So I can't check this answer, but I believe it's right. You didn't complain about the answer, right? Okay, how about this one again? So which formula are we gonna use this time? I don't think it's this. It's not that. We have sine first, cosine second. So I'm gonna go with this. All I need to do is make u into 82.5, v into 37.5, and simplify. Okay, so let's do it right here. 1 over 2 sine of, what happens if I add 82 and 32? 115, is that so? 115 degrees. And no, this is 37.5. So it is 125 then. 120. Yep, sorry. Has to be something you can compute by chart, so it makes sense. 120 makes sense. Sine of, and I subtract 82 and 37, it's 45. Alright, sine 120 is, it has a reference angle of 60. Sine in quadrant 2 is positive. So it's positive 60, which is 1 over 2. And 45 is root 2 over 2. So when I multiply with 1 over 2, add first 1 plus root 2 and multiply by 1 over 2, it's 1 over 4 of 1 plus root 2. Again, this makes 1 plus root 2 over 2, and I multiply by 1 over 2, it's 1 over 4 times 1 plus root 2 over 2. Okay? Alright. Now, what we are going to do in the next half of the questions is, we do right opposite. This time you have sum or differences, addition or subtraction. Again, when I say sum, minus and plus, both addition and subtraction are both considered sum. You have sum of pair of cosine or sine, either both cosine or both sine, or sine and cosine pairs. You turn them into products. It's opposite of what we did. So all you need to do is pick the right form. This is sine and sine couple. So for this formula, for this question, I'm going to go with number 3. I will use this side right here. But instead of x, what is my x and y? 5t and 12t. Instead of y, again, x minus y, I will do 5t and minus 12t. And just simplify. What is 5 plus 12? It's 17. 5 minus 12 is minus 7. We can do one more move here. What is that? Yes, we can take the we can just disappear this, clear this, because cosine is even function. Okay? I hope I can do this now here. Two 17 over 2. And cosine of 7 over 2, right? Yeah, again, I can't try. I need to update this plugin, so it's gonna give me an error again. But let me know if your answer doesn't work, but it should work, right? So we simplify and write it as a product. Alright, the next question. You have now cosine cosine couple. Get which one in the list are you gonna use? Which one? First, second, third, fourth? Second. So it is twice cosine of 7b 8b over 2 and cosine of 7b minus 8b over 2. Well, this is gonna make 15b. This is gonna make minus b. There is nothing you can do about the first one. 15 is not divisible by 2. But the second one, I will make it only positive b over 2, because a minus in cosine doesn't mean anything. Cosine is even function, minus just disappears. So this is it. Right? That's it. Alright, let's quickly try to finish this part. This is a verify identity type question. Whenever you see this statement, you need to pick a side and start with that side. Which side you think is most promising, most related to some product formulas? Which side? Which side has more potential? Left side. Okay, so I start with the left hand side, and I see on the left hand side a difference of cosines and a sum of cosines. Guess what I'm gonna do? For a difference, I will apply this formula. For sum, I will apply this formula on the top and bottom of the fraction. How did I get 4x and x? How? Technically, this is what I did. 5x plus 3x over 2. Well, 5 plus 3 is 8x. And that's how I got 4x here, right? I add u and v. I'm sorry, x and y. X is 5x, y is 3x, 8x over 2, which is 4x. And the second one is 5x minus 3x. 5x minus 3x is 2x, over 2 is x. Look at this now. Pair them up. These and this. Isn't that sine over cosine with different angles, 4x and x? So they make tangent, and these two cancel. Only a minus left. Minus 10 4x 10x. This is the right hand side, and the question is over. Okay? I believe the question here directs you the right path, step by step. So you need to first tell what formulas you're using, sum or difference. No, sum or not sum. This is called sum to product formula. And you do for x, for x, and x as I did, and the top is, wait a second, what is this? Simplify common factors, or they just canceling 2's. So the top is still sine 4x. And sine x. So they just wiped off those 2's. And we apply the quotient identity. This is called quotient. Sine over cosine is tangent. It's called quotient identity, and we're all set. Alright, but again, don't go with the connect math steps you do on your own and then go fill in the blanks. Alright. On Tuesday, tomorrow, we are gonna start 6.5.